Example 2. A wet steam from a turbine has a pressure of 53 bar and dryness fraction of 0.75. Determine the following properties of the steam: specific enthalpy and specific entropy. Now, first thing, as usual, you bring out your parameters, you state them, and you make sure that they are all in line. Now, first thing, like we did in the past, like we did in the previous example, we have something like, okay, firstly we write our solution out. Parameters given, never forget that. Parameters given. Yes, parameters given here are none other but the pressure. Of course, yes, the pressure. And I'm gonna rule this. Okay, I'm gonna rule this. Yes, the pressure P is 53 bar. Okay, and the dryness fraction X is 0.75, and we are supposed to find our H is unknown, our specific entropy too is unknown. So how do we do this? Now, from the saturated vapor table, we go back to the saturated vapor table and we get our values from there. So let's go to the saturated vapor table. Yes, and with my table, I don't know if you have yours, but in case you don't have yours, I can make it visible for those that don't have the table. So we have the pressure P. The pressure P, I'm going to rule it like this. The pressure P. Okay. Now the next is Vg. Of course, Vg. I'm going to rule it this way too, because it's a table. It's in a table form. In a tabular form actually. Our Ug, I roll it this way. Our HF will be ruled too. HF will be ruled. So our HFG will be ruled too. What else? Okay, we have our SF entropy of the liquid side. We have the SFG we rule to. Okay, yes, are we done? I think so. Now let's rule it this way, just like a tabular form. Okay, rule it this way. Yes. Now you have something like this: 50 bar. This is bar. This is bar. This is meter cube per kilogram. This one is in kilojoule per kilogram. Same here. The same here. Then here is kilojoule per kilogram per Kelvin, because this is entropy per Kelvin. So be mindful of your SI units. So from the table we have 53 and 55. So In case your table has 53, you can take the value and substitute immediately. But from the standard table, which is Reuters and Mail, is just 50 and 55, and we are given the pressure of 53, so we should interpolate to get it. We don't approximate, we make use of facts. So here, right here, for 50 bar, I have VG of 0.0394. At 53, nothing, we're looking for it. So at this, we have 0.03563. Then UG, at 50, we have UG of 2597. Then at 55, we have 2594. The HF, we have 1155. Here we have 1185. Okay. Yes, the HFG. The HFG, we have 1639. Alright. 1639. So I clean out the 5 like this. Okay. 1639. 1639. And at 55 bar, we have that is 1605. For the SF, we have it as 2.921. Liquid entropy at the liquid region 2.976. The SFG, here we have it as 3.052, and this as 2.955. Yes, we have all our parameters here. Now the problem is finding the one for the pressure P equal to 53. So how do we do this? We interpolate, and this is how we interpolate. Interpolating for HF. Let's start with HF. For HF at 53 bar. At 53 bar, so I'm going to rule it. Okay, I'm going to rule it this way. It's my heading. I'm going to rule it this way. Rather, clean it slant, so we don't need any slant stuff here now. So clean it. So interpolating. Yes, we have a straight line now, finally. So this is how you do it. You draw this down, you draw this, you draw this, I draw this. So the highest is 55, lowest, and we have 53 here. So HF at 55. The HF at 55, we scroll up and check. HF at 55 is 1185. Then HF at 53 is unknown. The HF at 50 is 1155. Okay? Now the formula for this interpolation here now is L minus L1 over L2 minus L1 That is the formula we are going to use. Is equal to what? X minus x1 over x2 minus x1. Remember, this is the 2, this is the one side. Okay, now this implies that 53 minus 50 over 55 minus 50 will be equal to HF 53 minus 1155 all over 1185 minus 1155. Okay, doing this over here, we have 3 over 5 is equal to HF53 minus 1155 over 30. Now collecting like terms, we have that HF53 minus 1155 is equal to 18. So that HF53 equal to 1155 plus 18, which will give us 1173. Now to check if your answer is correct, it should be in the middle or in between the value of 50 and 55. If it's higher than 55, you are wrong. If it's lower than 50, you are wrong. So the highest is 85, the lowest is 55. So 53 is 1173. That means it's correct. It's in between 85 and 55. So we proceed. Interpolating for HFG 53 units. Now, just like we did for the HF 53, the same thing you do here. You roll here. Here remains your pressure, and here remains your enthalpy. So pressure, highest pressure is 55, 53 and 50. What is the HFG at 55? HFG at 55 is 1605. We don't know the HFG at 53, so HFG at 50 is 1639. So the same procedure, you have your 53 minus 50 over 55 minus 50. That's for the left hand side. Alright, now which is equal to HFG on the right hand side, 3 minus 1639 all over 1605 minus 1639. So at the end of the day, we have that here will give us 3 over 5, which is equal to HFG 53 minus 1639 all over. That will give us minus 34. So we proceed. Now it becomes HFG 53 minus 1639 will be equal to 3 over 5 times minus 34. So finishing up, you have that HFG 53. Okay, HFG 53 will be 161.8.6 kilojoules per kilogram. Now check, is it higher than 1605? Yes, it is. Is it also lower than 1639? Yes, it is. So it's in between 1605 and 1639, just like 53. It's in between 55 and 50 bar. So that makes it right. So hence we calculate our total enthalpy. So there's no space here. I'll make another space to calculate the total enthalpy. Okay, total enthalpy. Calculate the total enthalpy. Now the total enthalpy will be HF H53 total will be HF at 53 plus X HFG at 53 bar. Okay, so that's HF53 will be, what do we get for HF53? We got 1173 plus dryness fraction, which is 0.75 into 1618.6. So finally our enthalpy will be 2386.95 kilojoule per kilogram. So that is the enthalpy we have here. So we'll move on to the next one. Okay, we'll move on to the next one. The next one is the entropy, specific entropy. So same thing happens in that specific entropy. So interpolating for SF53, interpolating for SF53, the same thing happens here. We rule, get a straight line. Okay, we can decide to bring it here. So we rule it this way, this way, this way. So here remains the 55 bar, 53 bar and 50 bar. And on the right hand side we have the entropy at the liquid region. Under 55 bar we have here to be 2.976. okay, and the SF53 unknown, SF53 unknown. Then the SF at 50 bar is 2.921. 2.921. So how do we go about this? It remains 53 minus 50 over 55 minus 50, which will give us SF53 on the right hand side minus 2.921 all over 2.976 minus 2.921. Okay, so if you watch very well, you see that the enthalpy reduced from 55 to 50 at the liquid region, while at the liquid and gas region it increased with decrease in pressure. Okay, decrease in pressure, while the entropy here at the liquid region under 53 bar decreased with decrease in pressure. So as pressure decreased, the entropy also decreased. So The entropy we should get here should be in between 2.976 and 2.921. So let's see how it goes. So we have that 3/5 is equal to SF53 minus 2.921 all over 2.976 minus 2.921. So finally we have that SF53 minus 2.921 is equal to 0.033, and then SF53 will be 2.954 kilojoules per kilogram Kelvin. Don't forget the assignment. So as you can see, it's in between 2.976 and 2.921. So we should be ready to get the final entropy. So final entropy at 53 is SF53 plus SFG53. Okay, so that's S53 is the SF. Okay, yeah, this is the general formula, but before this we should get the SFG. Alright, let's go and get the SFG because it's missing. We have to interpolate for that also. So having said this, I will hurriedly go and interpolate that. So interpolating for SFG53, I think this is the last interpolation. Okay, yes, so we bring it over here. Alright, and we will bring it over here. We roll. So 53, 50 as usual, 55. So for the SFG, what do we have? For SFG at 50, we have it to be 3.052. Here is the SFG. We don't know that. And then at 55, we have 2.955. So it remains 53 minus 55 all over 55 minus, okay, here it's supposed to be 80 from our formula. So it is 50, it is 52 equal to SFG53 minus 3.052 all over 2.955 minus 3.05. So just like I did before, I have this. So we can say that finally, doing the final calculation, we have that this is minus 0.0582 is equal to SFG53. So this is very far. Let me adjust it. Okay, let's adjust it. Let's look. Yeah. So minus 3 point. This is a minus. Don't forget that. 0.52. Okay. Yes. So having done this, finally SFG 53 will be equal to 2.955 kilojoules per kilogram Kelvin. Okay, now putting it here, you can see that it's higher than 2.955, and it's also the same time lower than 3.052, so it's in between them. So I've gotten that. So finally, to conclude, so in conclusion, we have that S53, just like we wrote before, is SF53 plus X SFG53. Alright, yes, SFG53. So SF53 remains 2.954 plus 0.75 into 2.9938, so that S53 will be equal to 5.1994 kilojoules per kilogram Kelvin. So as you can see, we have gotten our final entropy, gotten our entropy, gotten our enthalpy, just like the equation stated. We've gotten all these. So this is our table, gotten our enthalpy and entropy. So we've come to the end of this episode, so stay tuned for more videos. Thank you. Goodbye.
A little liquor and some ladies, yeah. We dey turn up on a daily. It's how I walk up, yeah. Soft walk,